Good afternoon, everyone. In this video presentation, we will be talking about electron affinity, one of the periodic trends in the modern periodic table. What is electron affinity? Electron affinity can be defined as the amount of energy released when an electron is added to a neutral atom to form an ion. It was a concept that was discovered in 1901 to view of the discovery of electronegativity by Linus Carl Pauling, as adding an electron to a neutral atom releases energy, or exothermic, an atom of an element with a large negative value has a high affinity for an electron. From the illustration, we notice that electron affinities become more negative from left to right across the row in the periodic table. On the left side, we can see that the lithium atom releases 60 kilojoules per mole when an electron is added. And on the right side, fluorine atom releases 328 kilojoules per mole when an electron is added. This shows that fluorine has a higher electron affinity than lithium. Although electron affinity is a precise and quantitative term, electron affinities are more difficult to measure. Hence, tables showing electron affinities measuring kilojoules per mole are created. Next slide, please. Electron affinity as a periodic trend increases going left to right across a period. This is due to the increased nuclear attraction. The electrons added to the energy levels get closer to the nucleus, making the nucleus and its electrons more attractive. Next slide, please. Going down the group, the electron affinity decreases. Since the electron is being added increasingly further away from the atom, they are less tightly bound and therefore closer in energy to a free electron.
Two types of electron affinity. First, electron affinity is the energy released when an electron is added to a neutral atom. 1 mole of gaseous atom gains 1 electron to form a gaseous anion. Next, the second electron affinity is the energy released when an electron is added to a negative ion. The second electron affinity is positive because more energy is required to add an electron to a negative ion as compared to a neutral atom. Next. Electron affinity depends on, first, extent of nuclear charge. An atom's nuclear charge is equivalent to its atomic number or the number of protons. As a result, the higher the atomic number, the stronger the attractive force acting on electrons and the greater the electron affinity. Second, size of the atom. The electrons on the outermost shells of an atom have a weak attraction to the nucleus. Hence, the value of electron affinity is low. On the other hand, atoms with smaller atomic size have higher electron affinity. Lastly, stability of valence shell electronic configuration. Elements with half-filled or fully filled subshells will have lower electron affinity because they are unlikely to accept an additional electron. Therefore, elements with unstable electronic configuration have higher affinity of electrons. Next.
What is the difference between electron affinity and ionization energy? Let us define first the two. First is electron affinity. Electron affinity is the amount of energy released when a neutral atom or molecule gains an electron from outside, while ionization energy is the amount of energy needed by a gaseous atom in order to remove an electron from its outermost orbital. Second is the energy of the two. Electron affinity describes the release of energy to the surrounding, while ionization energy describes the absorption of energy from outside. Next is the electron energy. Electron affinity is used to describe electron gaining because the amount of energy that gets released upon the acceptance of the atom from any neutral isolated gaseous atom to form a negative gaseous ion in the process. However, Ionization energy is used to describe electron removing because the positive charge on the nucleus of the atom does not change. And therefore, with each removal of an electron, the remainder are held more firmly. Lastly, the primary difference between electron affinity and ionization energy is that electron affinity refers to the energy released when an atom receives an electron. However, ionization energy refers to the energy required to remove an electron from an atom. Next.
So after talking about the differences, we will now talk about the similarities between electron affinity and ionization energy. First, both of them are energy-related terms. Again, according to their definition, electron affinity has something to do with the amount of energy released when an atom gains an electron, and ionization energy has something to do with the amount of energy needed by an atom to remove an electron, thus making them terms related to energy. Next, both of them are quantitative, since they deal with the amount of energy needed or released during a certain process. Electron affinity and ionization energy will be quantitative in nature. It is also worth mentioning that they are both measured in kilojoules per mole. Another thing is their values depend on the electron configuration of the subjected atom, which will then show that they both have a pattern in the periodic table. So for electron affinity's periodic trend, it increases for the groups from the bottom to the top, so basically upward, and then it increases as well from left to right across periods. So same with ionization energy, it increases from left to right across periods and also increases upwards in terms of groups in the periodic table.
Now let's talk about the differences and similarities between electron affinity and electronegativity. First, their similarities. Electron affinity and electronegativity are both known to be interrelated but are not interchangeable. Also, both deal with the movement of electrons. Next. Also, noble gases are not included in electronegativity for the reason that they don't want any electrons because they have complete valence shell. They also have the same trend, increase as you go across and decrease as you go down the periodic table. It's just like what is mentioned from the previous slides. Next. Now let's talk about the differences between electron affinity and electronegativity. Electron affinity, it refers to the amount of energy that is liberated whenever a molecule or a neutral atom tends to acquire an electron from the other elements. In short, electron affinity is the energy change when an electron is added to an atom, while electronegativity, it refers to the ability of the atoms to attract the electrons from the other elements. It is the strength of an atom, how strongly an atom pulls the shared electrons to itself. Next is electron affinity is applied to an atom or an atom present in a molecule, while electronegativity is applied only to a single or isolated atom. Next.
So continuing on the electron affinity and electronegativity, electron affinity, it has the tendency of releasing energy when electron is added. So every time an electron is added, the energy is being released. While the electronegativity, it attracts electrons to an atom without releasing energy. So in electron affinity, it is quantitative. It has unit of kilojoule over mole. While in electronegativity, it has no units because it is just the tendency of an atom on attracting. So it's basically qualitative. Next difference is the electron affinity. The maximum value of electron affinity is when the nuclear charge is more. While in the electronegativity, the maximum value of electronegativity is when the attracting force is high. So lastly, in electron affinity, The element with the highest electron affinity is chlorine, while the lowest is neon. While in the electronegativity, the highest electronegative element is fluorine, while on the other hand, the least electronegative element is francium.
Here are some examples where we can apply our knowledge of electron affinity. Example number 1. Arrange the following elements from most negative to least negative electron affinity: potassium, bromine, cesium, and chlorine. Next slide, please. Based on what we have discussed earlier, elements with most negative electron affinity values tend to have higher attraction for electrons. Electron affinity values become more negative from left to right across a period. They also become more negative from bottom to top of a group. Using the table as a reference, the order of electron affinities from most negative to least negative is chlorine, bromine, potassium, and cesium. This implies that chlorine is the most capable of forming an anion, while cesium is the least capable.
So next example, based on the periodic table below, which of the given atoms or element has the lowest electron affinity? So the given are A, strontium, B, radium, C, beryllium, D, calcium. So the answer would be B, radium. It is because look at the group in the periodic table uh, where the beryllium, strontium, uh, calcium, and radium are. So it is in the group of alkaline. So uh, it is uh, it is stated earlier that the electron affinity increases as it goes from bottom to top. So radium has the lowest electron affinity as it is on the bottom of the periodic table.
For example, number 3, it is likely that argon will form the anion argon negative. So for this question, we need to consider that argon has an atomic number of 18, that argon is a noble gas and it has an electron configuration of 1s2, 2s2, 2p6, 3s2, and 3p6. So since argon is a noble gas and noble gases are very stable gases, this is because they have a stable electronic configuration, as we can see from the fully filled p subshell right there, which is 3p6. So that means that argon will tend to resist any change in its configuration. So therefore, we can say that argon is chemically inert, making it unlikely to gain an electron and form an ion. So the answer would be no.
Example number 4. Which equation correctly represents the electron affinity of calcium? So for the first electron affinity of calcium, we start with the neutral gas phase calcium and form the anion calcium. Upon the addition of one electron, this means the answer will be E. That's all for today. Thank you.